Hello everyone, my name is Raymond, and welcome back to the next installment of the Project Feline Devlog series, a series about designing my own game from start to finish. We are currently up to the 7th installment of this devlog series, and to all the newcomers to the show, welcome on board. I'm super happy to have you here to experience this journey with me. If you'd like to see more about how this project began, be sure to check out the previous episodes in the playlist link below. So as always, I have a new game update to show you guys, and I have a new version linked in the description below, and upon opening it, you might notice that it looks exactly the same. It plays exactly the same. What the hell, Ray? It's been over 3 weeks since your last upload, what have you been doing? Now this is going to be one of those updates where on the surface it doesn't look like much has changed, but a lot has changed if you look under the hood. Lately I've been getting a lot of feedback and suggestions from you guys in the comments about this game. A lot of ideas about what sort of features to add in or how to adjust the mechanics. So all of this got me really excited about adding new features to the game. However, there was one small problem. To develop this game, I've been using the blueprint system in Unreal Engine. And while this is a pretty fun system to use, I'm still quite new to it, as I've only been using the engine for about 5 months. And due to the nature of being a beginner at this, I'm bound to make mistakes, and one thing I was noticing was that the more I was adding to this blueprint, the more complex it was becoming, and the more difficult it was to modify. I mean, look at this. I don't even know what's happening here anymore. I mean, that's just the event graph. Take a look at them function tags, man. So for the past couple of weeks, I've taken it upon myself to fix up my blueprints and make them clean and optimized. And in this episode, I hope to share with you what I've learned about designing cleaner and better systems for your games. So without further ado, let's get into it. Alright, so currently I have opened the Unreal editor as well as the map from my Project Feline game. And I'd just like to show you the old system I was using in comparison to the new way I've set this up. And then I'll show you how to do this yourself. Now, for this video, I'm going to be primarily talking about Unreal, but you can apply these principles to any object-oriented game engine. I'm also making this tutorial with the assumption that you have some basic knowledge on how to use Unreal's interface and how to create some basic blueprints. If you'd like more of an introduction to the engine, I'll link some tutorials down below. So I have my blueprints here, and there's quite a few of them. Let's take a look at my old Feline character at first. So this was the player character used in all previous versions of the game. And as you can see, it is quite cluttered. There's quite a bit going on. So not only does this handle inputs, but it also handles all of the logic and maths for all of the wall ride functionality, the double jump and stomp and slide functionality. And it's usually not a good idea to set things up this way. Firstly, you can see it starts to become a bit harder to work with, and it's also not reusable in any way, meaning if I wanted to create any other types of characters that had these abilities, I would have to copy and paste this blueprint for each different character. And that doesn't sound fun. If we look at my character, you'll see that she sports these cybernetic legs of some kind. I like to refer to it as the feline suit. And the suit is what gives the character its abilities. And just so you have an idea what the character can do, we can move, we can jump, and we can run on walls. We can also slide, can also crouch, and we can stomp into the ground. So all of those abilities were stored initially in here, but I've managed to redesign them in a way that's modular and reusable. In the comments of my last video, I was introduced to a concept called composition over inheritance. I'll link some videos below if you want to learn more about it, but the basic gist of it is that instead of defining objects by what they are, like inheritance, you want to define your objects by what they do. Now this is a bit tricky to implement in Unreal, seeing as if we look at the base classes in Unreal, they all rely on inheritance from the actor. So we can't eliminate inheritance altogether, but we can work with it. What I decided to do with my character was split the suit and the character apart and make them two separate entities. And the first thing I created was the feline suit component. And this is now the thing that contains all of the abilities and behaviors that the character will be able to use. I then created a special type of character derived from the default character class. This character knows how to use the suit. I then use this character as a base for any character I want to have these abilities. And I've made 2 examples. The first of which being the feline player and the feline bot. Now the feline player is quite simple. Because all of the abilities are stored in the suit component, You can see we have access to its settings here, such as the slide speed, the stomp speed. What we do in this blueprint is allow it to be controlled by the player. And you can see here, I've got some basic input mappings. I then used this Feline player as the base for the Gabriella character. And this is who you play as in the game. But if we open up her blueprint, you can see that by default, it doesn't show us the event graph at all. And if we wanted to look at it, you can see that it's almost completely empty. I haven't had to touch anything. All this blueprint contains is its own mesh and animations, and a few of its own settings for the character movement and the suit. So what this means is that we can create multiple playable characters in the game, all deriving from this Feline player. So there's how I've managed to clean up my systems for my game. I know there isn't a lot of new mechanics and features yet, but hopefully moving forward, development for this character will be a lot easier and faster. And I'm really excited to show you how things turn out. Now that you've seen how I've set it up, let's see how we can apply this to our own projects in Unreal. Alright guys, so I've just opened up to the default third-person template project in Unreal. So what we want to do is to create our own character and give it its own unique abilities. And we want these abilities to be created in a way in which they are clean and reusable. So first, let's have a look at the default third-person character blueprint it gives us. Upon opening it, you'll see that there's not much going on here. We just have inputs, such as jump, move, and rotate, and we don't see any movement logic in here whatsoever. We do see, though, that it calls references to certain functions, but what I want to know is where these come from. Well, as it turns out, this default character inherits from the base character class in Unreal. And this actor knows a little bit more about movement than its child, which is this playable version of the character. However, I want to know how we can implement the concept of composition to make reusable behaviors. If we look at the components attached to this character, we'll see it has a few ones like its collision and its mesh, but if you scroll down further, you'll see there's a character movement component. And this is the actual behavior that contains the movement logic. The only thing that the character class does is incorporates this knowledge to teach an actor how to move. And we want to set up our character in a similar way. And to do this, we're going to be making our own component like this, with all of our abilities and logic. We're then going to make our own character class, using the built-in one as a base, and we'll teach that character how to use the abilities. And then finally, we'll make a playable derivative of it that we can move around the map. So to start off, we can close this, and we want to go back to our content folder. And we're going to create our own folder called Blueprints. And we're going to open that up, and inside here, we're going to create a new blueprint. So we're going to right-click, create blueprint class, and you'll see we have a few options. We don't want to create a character yet. We want to create the behavior and the abilities. And if we look at this menu, you see we have the option to create an actor component, which is described as a reusable component that can be added to any actor. And this seemed really consistent with the idea of composition that I read about. Another way to look at this approach is to think of the actor component as the sacred Jedi texts, and the character as a Jedi Knight trained in the Jedi arts. So let's make our component, and we'll name this the sacred texts. And if we open that up, you'll see that we get just an empty blueprint graph. We'll delete these sample functions for the moment, as we won't need them. And for the sake of example, we're going to give this character the ability to dash and the ability to stomp. To do this, we're going to create a custom event, and we'll name this dash. Now the dash is going to launch the character forward in a particular direction. Luckily, the character class comes with a launch character function, which I use very frequently. However, if we try to use this, type in launch character, you see that it doesn't show up in our list. And that is because the sacred text is an actor component, not a character. To be able to access the character, we'll need to store it in a variable. So we're going to create a new variable, we'll call this character. And then we're going to change the type to a character object reference. So if we click here where it says character and select object reference, we should then be able to drag this into our graph, go get character, and we should be able to drag off from this and type in launch, and you see we get access to our launch character function. You can then click on that, and there it is. Now, this function needs two things to work. It needs the character to launch and the direction. Now, we could punch in some numbers here manually, but I wouldn't advise doing that, as we want to have the possibility to change the amount of dash applied to each character. So let's say we want Obi-Wan to be able to dash a further distance than General Grievous, for example. And to be able to do this, we want to store that direction in a variable. So we're going to create another variable and we'll call this dash direction. And we'll change the variable type to a vector. We can then drag this into our event graph. Now, if we were to plug this in immediately, it would launch the character relative to the world, not to the character. And later, when we make our stomp, we want this same rules to apply. So seeing as this will be a common behavior we use, we're going to do a bit of maths and store it into a function. To do this, we're going to go to the Functions tab and click Add Function, and we'll call this Orient to Actor. And this is going to take an actor and a direction and orient the vector to the actor and output it. So first we'll need to set up some inputs. So the first one will be the character, so I'll name this target. And we're going to change the type to an actor. We want to click actor, object reference. We also want to make a direction to take. So we'll call this direction, and we'll change this to a vector. And then lastly, we want to create an output, and we'll call this one relative direction. Cool, so now we can space these out a bit, and we'll add a bit of logic in between. Firstly, I'm going to drag out from our target and type in the following. I'm going to get actor right vector, going to get actor forward vector, and lastly, I'm going to get actor up vector. So this will get the general orientation of our character. We then want to pass our direction through these parameters into our return node. And to do this, we're going to times each of these vectors by a float. And we can copy and paste that node a few times. So we're going to multiply the character's orientation by these three numbers. And to pass this through, we're going to split our direction into a split struct pin. And this will split the vector into its X, Y, and Z direction. We then want to pass each of these through their respective oriented vectors. And then we can combine these all into one single vector to return. And to do that, we're simply going to drag off from one of these and do plus. And we want to select vector plus vector. We can then drag in all of our other vectors and then return this. We also want to make sure that this is indeed a pure function, as this is not really executing anything. This is just returning a value. Now that we have that in place, we can simply hop back to our event graph. We can then drag in our orient to actor function, and there it is. We then should be able to plug in our character and plug in our direction and plug this into the launch character node. And of course, we want to plug in the dash to this function. And now this should successfully launch our character. To make the stomp ability, it's more or less going to be the same. And to save on time, we can simply select this event and copy it and paste it down below. We'll need to name this event, of course, and we'll name this stomp. We also want to make sure that this uses a different direction than the dash direction. So we're going to delete this and create another variable, call this stomp direction. And we can drag this into our event graph and plug this into our function. Sweet, so if you want to be nice and neat, we can comment these off in their own little sections. Call this dash, and we'll call this stomp. Now, before we continue, it'll be a smart idea to set some default values to these variables. First, we'll need to compile and save our blueprint to make sure there's no errors. And you'll see that there is a default value, and it's currently set to 0. So let's punch in some numbers. Let's start with the dash. And for example's sake, I think 10,000 should be a good number on the Y, which is forward. And then I'm also, for safety, going to do negative 10,000 on the Z. And this is usually a good idea to stop the character from flying off ramps and the sort. I'm then going to go to my stomp direction, and we're going to set the default to negative 1500 on the Z. Cool, so there are our sacred Jedi texts. And now, of course, we need to create a Jedi Knight that can use these abilities. So we can close our sacred texts, and we're going to create a new blueprint. Except this time, we're going to be using the base character. And it seems only fitting that we name him Jedi Knight Character. And then we can open him up. So this is not going to be the playable character. This is only going to serve as a base character that knows how to use the sacred Jedi texts. So to be able to make this character distinguishable from a regular character, we need to add this behavior to it. You'll see up here there's a massive green Add Component button. And if you click on this and type in the sacred text, you'll see it shows up in the search, and we can plug it into our character. Let's hop over to our event graph. You'll see that it gives us some default functions, and we can get rid of these, and we're going to be making our own. For example's sake, I want the Jedi Knight to be able to perform the dash and the stomp, but I don't want the character to be able to stomp unless they are in the air. And I don't want them to perform the dash unless they are on the ground. So to do this, we're going to create some events, the first of which will be a custom event, and we will call this Start Dashing. And all this is going to do is run through some checks and then execute the dash function from our sacred texts. So as I said, we only want the dash to occur when the player is on the ground. And we can use the character movement component to check this. So we're going to drag in our character movement in. I'm going to drag off a node from this and type is falling, which is a function included in the character movement component. So we'll click on that, and you can see it returns the value of is falling, and we're going to plug this into a branch. We can then plug that in, and then when falling is false, we want to dash. So we can then drag in our sacred texts, drag off from that, and type in dash, and then plug that in there. Sweet. And then we want to do this again for our stomp. So we'll make another custom event, and we'll call this Start Stomping. And this time we want it to check the same thing, except we want it to execute the stomp if is falling is true. So to do this, we can simply take these parameters and copy and paste them in, link it up to our stomp event, and then we want to drag in our sacred text again, and this time type in stomp. And of course, this time we want this to happen when falling is true. Just to make things a little more neat, we're going to comment these off into their own little bubbles. So we'll call this Start Dashing, and this one will be Start Stomping. So now we have the base for a trained Jedi character, and we can use this to create all sorts of characters capable of using the Force. Before we continue though, you notice that we head back to our sacred texts, you see that the dash and stomp events are referencing the character, but we have not assigned this variable yet. So to ensure that it works, we'll need to tell our Jedi Knight to tell our sacred texts to use us as the base for these calculations. And to do that, we're going to head over to the construction script on our Jedi Knight character. We're going to drag in our sacred texts, and we're going to drag off from that pin and type character. And you can see we get the reference to our character variable, and we want to set our character. And we want to use our self as the variable. So we're going to right click and type in self, and this will get a reference to us. We can then plug this all in, make sure we plug in the execution pin. And now our sacred text will know what we mean by character. We can then compile and save. And now we should be good to go in creating a playable version that we can move around the level of this Jedi Knight. Now to create our player, we should be able to close these. Now to create our player, we can take a massive shortcut. If you're using the third-person template like me, we can actually have a look again at the default third-person character, and you can see it puts a lot of the inputs in for us. So what we can do is make a copy of this blueprint, taking all of the input logic, but instead make it a Jedi. So let's do that. So I'm going to click on the third-person character, I'm going to press Ctrl-C to copy it. I'm then going to go to my own blueprints folder and paste this with Ctrl-V. While we're here, I might rename it to Jedi Player Pawn. Sweet. Then we can open him up, and you see that it has all the logic from the default class. If you look at the top here, you'll see that it says parent class character, meaning that this is a direct descendant of our character. We want to change this to use our custom Jedi character that we set up earlier. And this is very easy to do. We simply need to click on class settings, and you can see we can change the parent class, and we want to scroll down and select our Jedi Knight. There he is. And you can now see it's changed its parent class to Jedi Knight character. So now we can start adding a few of our own inputs. Let's pick a nice empty space to do this in. So we're going to be doing something similar to the jump event that is included, except we're going to need to make our own inputs, and we're going to be plugging in our own events. We'll head over to the Edit tab, and we'll go Project Settings. We then want to scroll down to Input, and we then want to open up the action mappings. You see there's a few default ones in here for us, and we want to make our own. So we'll hit the little plus icon, and we'll create one. So we'll call this one dash, and we'll map this to left shift, and we'll give it a gamepad binding 2, do gamepad face button left, and we'll also add a mapping for the stomp. And we'll map this to the control button, and we'll also give it a gamepad mapping 2. We'll give it the face button right. Sweet, so we can now close all this and hop back over to our playable Jedi character. You'll notice that then if we right click in here and type in dash, you see that we get access to the input action event dash. We can then drag off from this pin and execute our dash. Now before you click on these, you see we get 2 options to choose from. We want to use the start dashing from our Jedi Knight character, as this will contain some rules as to when it can be used. And then we'll do the same for our stomp. So we'll type in input stomp, and we'll drag off from this and type start stomping. Sweet. So we can block these off into our own little comment bubbles if we want. And if we zoom out, you see that the blueprint is almost just as clean as the default blueprints it gives us. We should then be good to compile and save our blueprint. And just before we continue, there's one other thing we need to make sure of. So on our Jedi character, we have our construction script. But because this Jedi player was initially copied from the default third-person character, we need to make sure we explicitly tell this child of Jedi Knight to execute the construction script on its parent. So if you look at the construction script tab for our Jedi player, you can see that it is empty. So all we need to do is right-click on that construction script node and add a call to the parent function. We then need to plug these in, and then we should be good to go. Let's compile and save. Now, if you try to play the game in its current state, you'll find that we still get the default third-person character. So what we need to do next is to tell the engine to use our Jedi player instead of the default character. And we'll do this by creating our own custom game mode that will load in our Jedi character by default. To do this, we want to right-click and create another blueprint class, except this time we want to use a game mode base, and we'll call this Jedi Game Mode. We can then open this up, and over to the side here, you'll see some settings, and we want to search for the default pawn class, and we want to change this to our Jedi player pawn. We can then compile and save, and all we need to do now is to tell our project to load this game mode by default. To do this, we can go up to Edit, Project Settings again, except this time we're going to click on Maps and Modes and change the default game mode from the third-person game mode to the Jedi game mode. Once that's done, we can close this window, and we just want to delete this character from the scene. The game should now load our Jedi character into the level, and we should be able to run around, dash, and stomp. So as you can see, when we load up our level, we have our new Jedi Knight character. If we press the Shift key, we can dash. And if we jump and press Control, we can stomp into the ground. So that's how I managed to redesign my character class for the game. I think not only does it make the blueprint easier to look at, but it also makes it easier and faster to modify and add new abilities to the suit. I also managed to fix a few bugs along the way, and I've released an updated build of the game which you can download in the link below. I know there haven't been many new features added in this version, but I'm looking forward to keep developing with these new blueprints to develop some really fun gameplay. If you'd like to see more content like this on YouTube, be sure to subscribe and enable notifications so you don't miss the next episode. If you'd like to see more frequent updates on the game, be sure to follow my Facebook, Instagram, and Twitter pages. I've also opened my own Discord server for the project, just as a space where you can talk about the game or talk about your own game projects, game design, game development, art, music, anything creative. I'll have a link to the Discord server in the description of this video. If you'd like to support the production of these videos, you can do so on Patreon, like these top-tier supporters. Anyway, that'll do us for today. I hope that this video gave you something helpful to work with when developing your own games. I'd love to see what you make with this knowledge in the comments below. Thank you all so much for watching, and I'll see you in the next episode.